One of nature's many amazing gifts is a thing called the latent heat of fusion. Essentially, it means that in order to warm something up enough to change from one state to another, like changing these ice cubes from solid ice to liquid water, you have to shove in quite a lot of extra energy to convince the molecules to start jiggling around in a more liquidy kind of a way. So as these ice cubes take in energy from their surroundings, they warm up to 0 degrees Celsius, which is the freezing point. But they're still solid ice. In order to get them to change from solid ice to liquid water, still at 0 degrees Celsius, you have to put in an extra 334 joules of energy for every gram of ice. And that extra energy is what they call the latent heat of fusion. But here's the thing that blows my mind. Once you've done that and you've got liquid water at 0 degrees Celsius, you put in another 334 joules of energy for every gram, and you heat that water up from 0 degrees Celsius to 79 degrees Celsius, which is basically scalding water. And that's why the scientists are a bit worried about this whole Arctic sea ice loss thing. Hello and welcome to Just Have a Think. Now, just for clarity, no one's suggesting that the Arctic Ocean is going to start heating up to 79 degrees Celsius. That really would be the end of us. But the same principle of latent heat of fusion does apply in the Arctic, as we just looked at in that glass of water. As long as there's ice in the ocean, then all the heat energy is going into the ice, trying to get it to turn into water. But as soon as the ice disappears, then all of that heat energy from the sun can be devoted to warming up the water, and that will most certainly make several degrees of difference, with all sorts of pretty catastrophic consequences. So lots of research institutes keep a very close eye on the state of the Arctic each year, one of which is the National Oceanic and Atmospheric Administration, or NOAA, in the United States. NOAA produces an annual scorecard each December, and this is their latest one. It's a comprehensively peer-reviewed document which draws on a huge array of reference sources, all of which are now scrolling up on the screen behind me. I'll leave a link to the full report in the comments section below so you can go and have a look for yourself. And in the course of the next two videos, I'll be taking a look at some of the highlights from the report. The report actually considers a whole host of indicators in addition to sea ice. There are 7 vital signs outlined here: surface air temperature, terrestrial snow cover, Greenland ice sheet, sea ice as we've already mentioned, sea surface temperatures, marine algae and tundra greenness. Far more than we can possibly cover in a single video, of course. So I'm going to focus on sea ice in this week's video, and then we'll take a look at some of the other key points in subsequent programs. The report points out Arctic sea ice cover varies substantially over the year, with end of winter ice cover generally being 2 to 3 times as large as at the end of summer. Sea ice is an important element of the Arctic system. It acts as a barrier between the underlying ocean and the atmosphere. It limits the amount of absorbed solar energy during the summer due to its high albedo or reflectiveness, and it provides a habitat for biological activity and limits human access to the Arctic Ocean. This chart shows average monthly sea ice extent in March 2018 on the left and September 2018 on the right. The magenta line indicates the median ice extent during the period from 1981 to 2010. The minimum extent last year was on the 23rd of September, and this was tied with 2008 and 2010 as the 6th lowest extent on the satellite record at 1.63 million square kilometres, or 26% less than the 1981 to 2010 average. And the 12 lowest extents in the satellite record have all occurred in the last 12 years. According to the report, observations of Arctic sea ice extent have shown decreasing trends in all months and virtually all regions, with the September monthly average trend for the entire Arctic Ocean now standing at minus 12.8% per decade relative to the 1981 to 2010 average. The extent of sea ice, in other words the surface area that it covers, is relatively easy to measure, especially now we've got these satellites looking down on the whole shebang. But surface area only tells us part of the story about the state of the ice. If we want to get the full picture, We need to know how thick the ice is and how old it is. Older ice tends to be thicker and more resilient to temperature increases in the air and water compared to younger, thinner ice. In 1985, the oldest ice comprised 16% of the ice pack. In March 2018, old ice constituted 0.9% of the ice pack. That means it's gone down from 2.54 million square kilometres in March 1985 to 0.13 million square kilometres in March 2018. That's a 95% reduction. Measuring the thickness of the ice is much more difficult than measuring the surface area, simply because most of the thickness is underwater and therefore not visible. NOAA gets data from various sources, including a radar altimeter called ESA Cryosat-2, which has been operating since 2010, and more recently NASA's IceSat-2, which is a laser-based altimeter that provides an even more accurate picture. According to the report, the thickness increase from October 2017 through April 2018 was less than normal, resulting in a relative decline in mean thicknesses over the winter. Ice volume estimates representative of ice extent and concentration in the central Arctic verify the below average ice volume gain over this interval. NASA themselves also talk about Arctic ice thickness at their own website. Here's their take on the situation. The Arctic Ocean's blanket of sea ice has changed since 1958 from predominantly older, thicker ice to mostly younger, thinner ice. Working from a combination of satellite records and declassified submarine sonar data, NASA scientists have constructed a 60-year record of Arctic sea ice thickness. Right now, Arctic sea ice is the youngest and thinnest it's been since we started keeping records. So that declassified submarine sonar data then, well, as I've mentioned in a previous video on this subject, if you're spending several months of the year patrolling and surveying the depths of the northern waterways, you will need to surface from time to time, and when that happens, you'll find it extremely helpful if you know how thick the ice is that your submarine is going to have to break through in order to hit fresh air. So the US Navy make it their business to know more or less to the millimetre exactly how thick the ice is. And thanks to Patrick McNulty, whose ocean mechanical thermal energy conversion design we featured a few weeks ago, and who runs a Facebook forum called Ocean Tunnels, we have access to those declassified charts. In fact, Patrick's been able to provide charts that allow us to look at maximum and minimum levels for every year from 2012 right up to just a couple of days ago, March the 7th, 2019. Let's look at the March charts first of all, which show the maximum coverage for each year. If you look at the colour key on the right hand side, you can see that the scale goes from the very dark reds at the top, indicating ice thicknesses of 5 metres or more, down to the very pale purple at the bottom, which denotes thicknesses of less than half a metre. In March 2012, the majority of ice in the open water was between 2.5 and 4 metres thick, with some 5 metre thick ice clinging to the southern coastlines. As we go through the years, you can see that the very thick ice is beginning to decline, and by the time we get to 2017, there's far less of the yellow and red colours at the land's edge. By March 2018, those colours had all but disappeared completely. And here's what the Arctic sea ice looked like on Thursday of this week. Not only has the thick ice not reappeared, but if we flick back and forth briefly between this year and last year, you can also see that the open water ice, which last year was mostly in the 2 to 2.5 metre range, is now firmly down in the 1 to 1.5 metre range. Back at the NOAA website, they make a further worrying observation. One of the more remarkable features of Arctic sea ice over the past year was the dearth of ice in the Bering Sea through the 2017-18 ice growth season. The Bering Sea supports a vibrant sea ice ecosystem with abundant seals, birds and other species that critically depend on the timing of the sea ice formation and retreat. It's also an important commercial fishing region. Ice typically begins to form in the Bering Sea around the beginning of October and expands through the winter before melting away through the spring. According to NOAA, for virtually the entire 2017-2018 Bering Sea ice season, the extent was at a record low. During February 2018, typically the height of the winter season, the Bering Sea actually lost significant ice cover. From the 7th of February to the 23rd of February, ice extent decreased by about 215,000 square kilometres, dropping from around 59% to only around 26% of normal levels. And this report from March the 7th, 2019, by Andrew Friedman for the website Axios, tells us that it's happened again this winter. For the second straight year, Friedman says, the Bering Sea, a turbulent and bountiful stretch of the northern Pacific Ocean, is virtually ice-free at a time when it should be gaining ice. This is the richest fishing ground in the US, featured in the Discovery Channel's Deadliest Catch. Friedman spoke with Rick Thoman, a scientist at the Alaska Center for Climate Assessment and Policy. Thoman's view was this: 1 year maybe is a fluke, 2 years sure looks like we've crossed the threshold now. Zach Laib, a PhD candidate at the University of California at Irvine and creator of these superb graphic representations of Arctic sea ice loss since 1979, also contributed to the Axios report, saying, although the past 2 years have brought historically low Bering Sea ice conditions, year-to-year trends there can fluctuate considerably. Laib goes on to say, some years may see temporary upticks in Bering Sea ice extent, but that overall climate change is now in the driver's seat. The impact of this dramatic reduction is significant, says Friedman. March is normally when people would be crabbing and fishing out on the ice. That's not happening now. Communities exposed to high seas are seeing severe erosion and threats to their infrastructure. The loss of sea ice could change ocean temperatures, salinity and currents enough to alter the distribution and abundance of commercially valuable fish in the region. The stakes are high here, as the Alaska pollock fisheries alone was worth $413 million in 2017. It also portends consequences for the lower 48 states and beyond. In a new study published in Earth's Future on Thursday, scientists warn that Arctic climate change is already reverberating far outside the region. So what about the September minimum sea ice levels again? Well, let's go back and have a look at those Navy charts from Patrick McNulty again. This chart shows the September minimum from 2012. Obviously you can immediately see the dramatic difference between the winter maximums we looked at earlier and the summer minimum shown here, but that's perfectly normal. What you can also tell from the colour key though is that back in 2012 there was still a fair quantity of that old multi-year 4 and 5 metre thick ice just above Greenland and the Canadian archipelago. The thicknesses were similar in 2013, and then we see quite a bit of variability in the subsequent years running up to 2017, by which time there really is very little multi-year ice left. Then when we arrive at last September's chart, although the surface area coverage looks relatively large, you can clearly see that it's an almost universally thin layer, less than a metre thick and even right down to only a few centimetres out in the open waters. This wafer-thin ice is extremely vulnerable to being broken up by severe weather. One big storm and much of that light pink stuff may well have disappeared. Unsurprisingly then, the greatest level of concern and anxiety, and frankly speculation amongst the climate science community, is about if and when the Arctic will become ice-free in September, with the consequent very rapid warming of the water that we looked at right at the start of the programme. It's what's come to be known by the climate scientists as a blue ocean event, or BOE. Now, just for clarity, when they say ice-free, they actually mean a quantity of ice that's less than 1 million square kilometres, which still sounds like an awful lot of ice. But in the context of a maximum extent of about 15 million square kilometres and an average minimum of about 6 million square kilometres during the 80s and 90s, 1 million square kilometres is actually a statistically insignificant quantity. And crucially, it won't be one big blob of ice in the middle of the water, it'll be little pockets of ice here and there, much of which will be clinging to the shorelines, leaving the vast quantity of open ocean exposed to the full force of the sun's heat. Some of the more strident climate commentators have been predicting a blue ocean event every year for the last several years. Well, it hasn't happened yet, and NOAA's stated rate of decline in surface area of 12.8% per decade that we looked at earlier would suggest it may not happen until the end of the century. But the Navy charts of ice thickness do seem to suggest a rather more urgent dilemma, and given what we can see on this latest chart from just a couple of days ago, it looks likely that this year's September minimum ice cover may well turn out to be the most fragile and vulnerable layer of ice yet. One thing's for sure, if and when we do get a blue ocean event, our global climate will change very rapidly and very significantly, and most likely irreversibly. There's much more to digest from this fascinating report, so as I mentioned earlier, we'll definitely be returning to the subject in future videos. But that's it for this week. I hope you found the video informative and helpful. If you have, please do give us a like and share the link with your social group. We've actually just this week reached another milestone in the channel's development as we've passed through the 5,000 subscriber mark. So a massive thank you to those of you who've subscribed in the last few weeks, and special thanks to those of you, and you know who you are, who've steadfastly stood by and supported the channel right from its creation about a year ago. I think it's fair to say that without your words of encouragement, the channel wouldn't be at the stage it's at now. So if you haven't already subscribed, please do consider joining us so we can start marching towards the next milestone of 10,000 subscribers and getting this vitally important information out to as many people as possible. It's absolutely free to subscribe and it's dead easy to do. You just click on this icon here. As always, thank you very much for watching. Have a great week and remember to just have a think. See you next week.